Hello my dear students, this is Akash SD and welcome to the ASD Physics classes. Hope so doing really great. So students, in last video we have covered electric field intensity due to conducting and non-conducting sphere. In this video we are going to see electric field intensity due to infinite thin sheet and infinite thick conducting sheet. Now the question arises, what do you mean by the infinite sheet? Actually, you have to understand one thing, the sheet is not infinite. The concept is very simple. The observation point is very close compared to the size of the sheet. Let's take for example, the area of the sheet is for example 10 meter square, but the observation point is just 5 centimeter, 10 centimeter. So in this situation, we can consider even that sheet also which sheet? Infinite sheet. Okay, so I hope so you have understood very well what is the meaning of the infinite thin plane sheet. So let's start it here. So let charge is uniformly distributed on the thin sheet having surface charge density sigma. After that, EFI at any point can be calculated easily by taking cylindrical Gaussian surface as shown in diagram here. So here I have taken one thin sheet and let's take here some charges there. No? By default we will take which charge here? By default we will take here this positive charge here. After that, let me draw here the one Gaussian surface. So I have taken the Gaussian surface like this here. Okay, this is my Gaussian surface. And here this is my observation point. So I will draw here like this here. Let's see please. Okay, this is my Gaussian surface is there. After that, if I talk about here the electric field, you know very well electric field is always away from the positive charge. That means at this point electric field in which direction? This direction. E, is it? Similarly, if I write in a vector form actually, so this is which one? Right side. So we can write here ER equal to magnitude E and direction I cap. Similarly, if I talk about here the area vector from the closed surface, where? Always outward. That means here. This is what area vector here, and this area vector is also given by magnitude A and direction I cap. This is here. Okay. Similarly, if I talk about here at this side area vector, which side? This side here. So here I can write here A left is equal to A minus I cap. I am writing in a vector form, very standard form. Okay. After that, if I talk about here the electric field in which direction? Again, anyhow, in this direction, and here we can write here magnitude is E only, but in a vector form, EL equal to E into minus I cap. Okay. And after that, we have to apply the Gauss law, and for that, what we need? How much charge enclosed? So let's take here in this region. In this region, some charge is enclosed here, na? In this region, some charge is enclosed. And let's take this area, cross-sectional area, how much here? This cross-sectional area is A. Then can you guess how much charge is enclosed? This enclosed charge is given by sigma surface charge density into area. This is the enclosed charge here. Now we will apply the Gauss law. So according to Gauss law, what we know? Total flux is equal to charge enclosed by epsilon naught. Is it? Now, which kind of flux are here? You can guess. Left surface. Where is the left surface? Left surface, right surface, and which one? This curved surface. So I can write here. Let's take here. I will write here phi right plus phi left plus phi curved, and this charge enclosed. Charge enclosed, how much we got here? Sigma A by epsilon naught. Now after that, we'll put the value here. For the right surface, you know electric field, right side, area vector also. Right side, even you can use dot product also, but I will do in a very simple way. So EA cos 0. You can do dot product also. ER dot AR also. Very easy. What is phi L? Similarly, phi L, how much here? Electric field is E. Area is also A. So again, I can write here EA cos 0. And curved surface. What do you mean by the curved surface? You know electric field is along the curved surface. Electric field lines are not going to curved surface. That means here what will happen here? It will come here 0, and it is come here what is sigma A by epsilon naught. So here EA plus EA plus EA, what will come here? 2EA, is it? So let me write here. This 2EA is equal to, we can write here sigma A by epsilon naught. This A and this A cancelled out. That means electric field is coming how much here? Electric field is coming sigma by 2 epsilon naught. Is it? This is the magnitude. Similarly, if I want to write in a vector form, which form? For example, no, we should know the standard one. So if I want to write which side? Right side. So here we can write here sigma by 2 epsilon naught I cap. Okay. Similarly, if I write left side, so left side is what? along the negative x direction. That means sigma by 2 epsilon naught minus I cap. I hope so you understood very well. Is it? Next one, students, we are going to see some cases, very important for the exam point of view. Let's see here, EFI cases of multiple thin sheets are here. Okay, so let me see here. Here I have taken the 2 sheets here. Here I have taken, let's take charge is plus sigma. Here also charge how much? Plus sigma is there. Okay, and I have taken some point is there. No? This is point A, this is point B, and this is point C. This is my which case? First case. First case is there. No? So first let's calculate the electric field at point A. No? At point A, B, C, we will do the electric field due to this white color one here. No? So this is which one? Positive one. That means electric field is away in this direction. I can write here. This is positive now, so I can write here, for example, E plus sigma. Okay. Similarly, at point B also, which direction? Away. Here also we can write here E plus sigma. Is it? Similarly, at point C also, which direction? Away, E plus sigma. You can match white and white I am doing here. Similarly, if I do for the yellow color actually, na? This sheet if I take here. So here also electric field in which direction? Away. That means here, this is the positive charge. Electric field in which direction? Away. At point A only, but in this direction here, away. So I can write here E plus sigma. Similarly, here also electric field is away, E plus sigma. And here also electric field is away. That means how much? E plus sigma. That means, students, you can see if I talk about at point A. So at point A, what is happening? Both the electric field in which direction? Same direction. I will just write in a vector form so that you can see very well here. So due to this white color, we can write here sigma by 2 epsilon naught minus I cap, and this one due to yellow color, again sigma by 2 epsilon naught minus I cap. That means what this will come here? It will come here sigma by epsilon naught minus I cap. Is it? Similarly, if I talk about at point B, so at point B, what will happen that here, students? So electric field, this is at point A, this is at point B. At point B, how much? Both the electric field in which direction? Opposite direction. That means we can write here sigma by 2 epsilon naught. One is due to white color, I cap, and due to yellow color, sigma by 2 epsilon naught minus I cap. And how much coming here? Null vector. That means no electric field between the sheets having the same kind of charges. Similarly, if I talk about at point C, now at point C you can guess very easily. Directly I will write here both in same direction, so both will add up. That means it will come here sigma by epsilon naught, and here it will come here I cap. Is it? So this one we have considered case number 1. Is it? Just see here very well, because after that I am going to do for the case number 2, and case number 2 you have to only just guess how we are going to do here. Let's take for example here, again I have taken here this charge I have taken. Let's take for example, now minus sigma I will take here. This is minus sigma. Here also minus sigma is there, and again I have taken here point A, B, and C. Now again in the same way we will do here. Now in a very relaxed manner we will do here. Okay, so see here please, due to this positive sheet. Now so negative charge means electric field in which direction? Always towards. That means here E minus sigma. Here at point B, again towards E minus sigma. Is it? And at point C also towards E minus sigma. Okay. After that, students, if we draw for this another one, this one is also yellow color. So here also in which direction? Towards E minus sigma. Here also towards E minus sigma. And here also at point C also towards E minus sigma. Is it? Now I will directly write the values here for the case number 2. So electric field at point A is given by, you can see both the electric field is going to be add up. Is it? So sigma by epsilon naught I cap. Is it? Similarly, this is the at point A. Now after that at point B, how much? See, both the electric field in which direction? Opposite direction. It will cancel out here. 0. Okay. And at point C, how much here? Again, both the electric field in which direction? Same direction. So again, both will add up here. So sigma by epsilon naught, and here minus I cap. You have to just take the reference from the first situation. Okay. Very easy. Next one, students, we are going to see the third case. Here what we are going to do, here we are going to take the opposite kind of charges. Let's take here for example, here I have taken plus sigma, and here I have taken minus sigma. Very important for the capacitor point of view. Okay. So here what will happen that here if I take some points here, let me again take the point A, point B, and here point C. Now Let me draw here the electric field. Which one is there? Positive charge. So positive charge means always away. So this is here E plus sigma. No, E plus sigma. Let me decrease it somewhat. After that, here also away. This one E plus sigma. Here also at point C also away. E plus sigma. Now after that, if we see due to this one, white color sheet is there now. Minus, that means in which direction? Towards. That means here E minus sigma. Here also towards E minus sigma. And here also towards, and here how much there? E minus sigma. You know magnitude of the electric field is same. How much? Sigma by 2 epsilon naught. So at which points electric field will be 0? At point A, and at point C electric field will be 0 because it will cancel out. So if I talk about here at point A, so at point A how much? Both the electric field will cancel out. It will come 0 here directly. Similarly, if I talk about here at point C also both the electric field will cancel out 0. But at point B I will write in a very standard vector form because very important. EB is equal to, first I write due to the white color, this white color. So it will become here sigma by 2 epsilon naught and here I cap. Similarly, due to this yellow color, again same story, sigma by 2 epsilon naught I cap. So when you will add this, what it will come here? Sigma by epsilon naught I cap. Is it, students? So see how much easy way we have done this here. Okay, so these cases are very important in a exam. Next one, students, we are going to see. Now fourth application, electric field intensity due to uniformly charged infinite thick conducting plane sheet. Thick conducting plane sheet means just like your notebook. Whenever you will see your notebook, two sides will be there, na? Left side and right side. Here also I have drawn here the two sides, one by the yellow color and another one by which color? White color. Okay, so let's see please first. Let charge is uniformly distributed on the thick conducting sheet having surface charge density sigma. Electric field at any point can be calculated easily by taking cylindrical Gaussian surface as shown in diagram. Okay, so again I am going to take here the cylindrical Gaussian surface. Now let's take here this. I have taken the cylindrical Gaussian surface like this. Story is same only, but little bit difference will be there here. Okay, and what will happen that here? Let me see here again. Let me distribute here the charge. So see here please, here two surfaces are there. So see please here, this side I have taken some positive charges. No, this is on the white color of sheet. Another one yellow. This is where backside. Is it? So what will happen that students here? If I draw here electric field due to positive charge in which direction? This direction. Electric field is E only, but in a vector form I will write here ER equal to EI cap. And area vector in which direction? Area vector in which direction? Again outward only, this one here. AR equal to A into I cap. Okay. Now after that, if I talk about left side here also electric field in which direction? Away. Standard form EL is equal to E into minus I cap. Area vector in which direction? Again closed surface now outward. So AL is equal to A into minus I cap. Okay. After that, what will happen that here, students, if I talk about here the surfaces. So you can see one backside surface will be there. I have drawn with the yellow color. And after that, which surface will be there? Front surface will be there. I have drawn here with the white color. So can you see two surfaces are there? Is it? And you know very well the surface area. This surface area, how much here? This surface area, backside also A, front side also A. That means how much charge enclosed? Here charge enclosed is given by surface charge density into 2A, because backside area, front side area. Okay. Now after that, if I use the Gauss law, students. So according to Gauss law, what you know? Again, total flux is equal to charge enclosed by epsilon naught. Is it? Now again, which surfaces are there? Just like a previous situation. We can write here right surface, left surface, curved surface and charge enclosed here. Sigma into 2A by epsilon naught here. Now right surface how much? Again I am interested in the magnitude. I want to do very easy thing for you, so only magnitude here. Here E, this is A, both in the same direction, so EA cos 0. Is it? Similarly left side here magnitude E, area magnitude A, so EA both in same direction, so EA cos 0. Curved surface 0, as I told, electric field lines are parallel to the curved surface, and here what will come here? Sigma into 2A by epsilon naught. Okay. Now we'll go to the next one, students here. If we add both of them, EA plus EA, 2EA. is sigma into 2a by epsilon naught. Okay. After that, what will happen that here? Both the sides, what will cancel? This a and this a cancelled. This 2 and this 2 cancelled. That means electric field, how much coming? Sigma by epsilon naught. Okay. If you write in a vector form also, so right side vector form, what you write here? Sigma by epsilon naught I cap. Left side vector form, if I write here, sigma by epsilon naught minus I. Can you see one interesting thing? This electric field is similar to which one? Similar to this situation here. Here you can see students at point, not this, wait, this one here, similar to which one? Positive charge is there now, so this one here, similar to this one here. Now, so a thick conducting sheet can be considered as two thin plane sheets here, and here also electric field at point A and at point C, how much here? At point A and at point C. So sometimes question will come, remember that a thick conducting sheet is similar to two thin plane sheets having the charge plus sigma. If on that sheet they have put the negative charge, then it will come here minus sigma depending upon the situation. Okay, so these derivations you have to understand it, students, very well. Now we are going to see one very interesting thing, finite sheet concept. Because as I told you, there is nothing like an infinite sheet. Always sheets are finite, but what will happen? Observation point is very close compared to the size of the sheet. So let's hear please here, if observation point is very close to the sheet compared to its size, then for the thin plane sheet, you know very well, electric field formula is what? Sigma by 2 epsilon naught. But here you have to remember that one thing. Let's take here charge on this is Q and this area, this area, very thin sheet, this area is A. So here sigma will be how much, students? Here if I write here the sigma will come here Q by A. Yes or no? This value I will put here. So what this will become here? Q by 2a epsilon naught in terms of charge here. We have got this. Now if I talk about here, in this situation, here how many surface area is there? 2, because thick conducting sheet, the charge will be on the surface. So one is backside, this yellow color, backside, this area how much? A. After that front side here please, this one here also one area is there. So total area how much here? A back, A front, that means total area how much? 2A. That means here if I write here sigma is given by Q by 2A, is it? Now if I write here the electric field, what is the formula? Sigma by epsilon naught, but just put the value of sigma. So what this will come here? Q by 2A epsilon naught. So here you have to understand that one thing in terms of surface charge density, sigma by 2 epsilon naught, but if we talk about here the charge, then value same, Q by 2 epsilon naught, Q by 2 epsilon naught.